I said no.
Did you get that?
What's your problem? You're short.
You win. I should have.
Well, then you couldn't learn.
I was turning in my assignment.
The only reason I didn't is because then Sue emails me right away.
Because I'm so nice, that's why.
Yeah.
It's because
Okay.
deep down bosses love this.
Oh, yeah.
Sometimes
Not
I'm
you,
like,
Owen, just.
All right, so we are going to get started.
So.
Yesterday we learned, well, actually the last 2 days, we learned how to graph sine, cosine, and tangent. And today we're gonna learn how to graph secant, cosecant, and cotangent, okay? If you look at cosecant here, what you're gonna notice when we graph cosecant, do you guys remember how sine is the reciprocal of cosecant? Everybody remember that? Okay, and that is on your cheat sheet too. So whenever you graph secant, or I'm sorry, cosecant, you're gonna graph the sine function first. And once you graph that, everywhere that your sine function crosses the x-axis, you are going to have a vertical asymptote. So notice everywhere my sine crosses the x-axis, I have a vertical asymptote. And then at the tip of each of these, like the high point and the low point of my sine function, that's where you do your cosecant function. So this red in dashed lines, that's sine. The actual graph for cosecant is what is in blue here. But you need to do that sine function to know where to start and stop your cosecant, okay? Same thing with secant. When you go to graph cosecant, or secant, sorry, cosine is, yes, 1 over.
Just doing both then, right?
You're gonna do them both, yes.
Yeah.
So, and when you're graphing the sine and the cosine, it's so that you know where your cosecant or secant is gonna start and stop, where those asymptotes are, okay? And then cotangent, do you guys remember tangent yesterday had, let me go back here. Do you remember how tangent had its asymptotes at -90, 90, 270, and so on?
Yeah.
And the tangent also started down low and came up high, okay? Cotangent, the only way cotangent's different, the asymptotes, instead of being at -90 and 90, the asymptotes are at 0 and 180. So that's one difference if we go back. Notice the red here is your tangent, and you don't have to graph that when you're doing tangent. In fact, I wish the red wasn't on here. We're really just looking at the blue. So the vertical asymptotes for cotangent are at 0, 180, 360. And tangent started low, came up, and went up high. Cotangent does the opposite. It starts high and goes low, okay? So those are the 3 that we're going to do. This chart should be on your cheat sheet in case you're wondering which one is the reciprocal. And then, yeah, we may be using those too. So let's go here. Oh my gosh, my foot is so itchy right now, sorry. All right. So we're gonna graph cotangent, okay? And do you guys remember what I said, where your vertical asymptotes are for cotangent?
0 and 180.
0 and 180. So at 0 and 180, and then just follow that pattern, would you get the next one would be at 360?
Mm-hmm.
And then over here, where would they be?
-360 and -180.
Yep.
You're lying, actually.
Okay. Now, would you guys know that the cotangent is gonna cross the x-axis halfway in between here.
Yeah.
And with cotangent, what did we say? Does it start high and end low, or does it start low and end up
Low to
high?
high.
High to low for cotangent.
Oh, sorry,
Tangent,
wrong one, Bob. Sorry.
yeah, tangent did the, I'm sorry, but my foot is so itchy right now. So that is what we would have.
Vaughn, does it honestly matter the order you put it in if it comes out the same shape?
What do you mean by order?
Like, watch me start at the bottom and go to the top. And it came out the same.
Oh, yeah, that's fine. As long as you know.
Start from the top left, work to the top bottom. Every time. Every time.
All right, are we good? Everybody understand that?
Jesus.
I was gonna ask that yesterday when we did the tangent. 'Cause she said
You
start
don't
at the
have to
bottom and
ask
go top.
that. You won't know.
I
which way you
should say,
go.
on the left, you start on
Because
the
it's-
top.
Look at your pencil marks with like a magnuscope.
Because as long as it gets the same shape, it doesn't matter where
And
you
if he
start.
does, then that sucks for you.
I guess what I'm saying, Owen, is where do you start on the left?
Wrong?
Well,
So like
I know
cotangent,
that these ones are cotangent, the other, the opposite is tangent.
there you go. All right. So now what we're gonna do is we're gonna look at a graph with cotangent that has a number in front of it. That number, we don't even worry about, okay? If they ask you for the amplitude, this is important, you guys. If they ask you for the amplitude of anything besides sine and cosine, oh my gosh. I am like just
I think we
dying
just need
here.
to stop the last
Chair, I'll push you around in that chair.
Okay, so if they ask you for the
You know what she
amplitude,
needs? She needs gold bond foot powder.
if they ask you for any of the six, the only two that you list the amplitude on is sine and cosine. If it asks you for the amplitude of cotangent, you say none, okay?
Even if it's
So-
not one.
I say no.
Yep, even if it has a 3 in front, you still write none, okay? So now let's do the period for this. Do you see how there's a 2 in front of theta? Do you know that that 2 is your B? Okay, so what we would do here is we would go 180 divided by 2, which is 90, okay? What does that mean then?
Every 90 is a period.
Yes, every 90 is a period. Now, there's a couple ways that you could do this, but what I do is I do this to find out where my asymptotes are. So I would let B times theta, which is 2 theta, equals 0. And if you don't like using theta, you can do 2x equals 0 and 2x equals 180. Here, aren't you going to get 0? And here you're going to get 90. This tells us where our asymptotes are. Once you find that out, would you guys get that you're going to have one here?
So pretty much everywhere we just marked, or we just found out with the period.
Yes. So you're just going to have double the tangent or cotangent functions labeled. And you want to make sure that you have your asymptotes in the right spot. And then in between each of these is going to be your x-intercept. And remember, cotangent starts high, goes low, from the left to the right. Okay? So you should get something that looks like this. Everybody good? Okay. Now if we look down here, notice, again, we have this 2 in front of the cotangent. Do I have to worry about that? No.
No.
But do you guys get that B is a half, right? So wouldn't this be 180 divided by a half, which is the same thing as 180 times 2, which is 360. So what that means is this time my period is going to be 360 degrees. And if you go to find out where those asymptotes are, you could set the 1/2. If you don't want to use theta, you can use x equals 0 and 1/2 x equals 180. How would you guys get rid of the half? Times it by 2. Okay. So over here, I just get this is gone. 0 times 2 is 0. If I multiply this one times 2 and this times 2, x is going to equal, this is gone. 180 times 2 is 360. Okay, so I can go over here. This is where my asymptotes are. So that means at 0, I'm going to have a vertical asymptote, and at 360 I am. For cotangent?
Yeah.
Not with what we learn later, but for today, yes. For today, yes. For a cotangent. So then I have one here, and would you guys know that cotangent would look like that?
Yeah.
And like that?
Yeah.
Everybody good? All right. So now let's look at this page. So now what we're going to do is graph cosecant. And cosecant, you guys, cosecant is the reciprocal of sine. So when you're doing cosecant, you always want to graph the sine function first. Once you get that, it's easy to do the cosecant. So it's like you're just graphing sine like we did yesterday. Do you guys remember with sine, where did we start? At 0. And where did it go up to? What was the amplitude?
1.
1. So I'm going to make this 1 and 2. I'm going to make this -1 and -2. And with sine, I start at 0. Do you remember what happens at 90? 90, you're up at 1. 180, you're at 0. Do you guys know how to find that if you didn't know? If you look at your unit circle, sine at 0 is the second thing, and it's 0. Sine of 90 is the second thing, it's 1. Sine of 90 is the second thing, it's 0. Sine of 90 is the second thing, it's, or I'm sorry, that was 270. So that tells you where they are. So it goes like this. Okay, so you're going to have your graph like that. And then you just want to keep that pattern going.
Yo, where's the numbers on this graph?
What do you mean by that? So no, this is sine. This is not cosecant. So now what you do on these is everywhere it crosses the x-axis, it's going to be undefined. So you have to draw a vertical asymptote. That's what that means. And it's because if you did the reciprocal of 0, what's the reciprocal of 0? Undefined. So where you see zeros on sine, you're going to have a vertical asymptote. Okay, then what you're going to do once you draw those asymptotes, you go to the, this is called the peak of your graph. You go here and you just draw an upward U. This is the cosecant graph. Then this is actually called the trough of your graph. It's the lowest point. You start there and you go a downward U. Then you go to here and you draw the upward U. Go here and you draw the downward U. So do you guys get the pink is sine, the green is cosecant? Everybody get that? Okay. So now we're going to do the same thing, but we're going to graph secant and cosine because secant is the reciprocal of cosine. So we're going to just draw a general cosine graph. And again, if you're not good at memorizing what they are, use your unit circle. At 0, cosine is the first thing in the ordered pair. So it's 1, then it goes to 0, then it goes to -1, then it goes to 0, and back to 1. So if I made this 1 and 2, like that, cosine starts up at 1. At 90, it's going to be 0. At 180, -1. At 270, it's 0. At 360, it's up. So your cosine graph looks like this. And then if we repeat that pattern, like that, okay, that is just the graph of cosine, okay? So what do you think I would do everywhere it hits the x-axis? The vertical asymptotes, yep. So here I'm going to draw vertical asymptotes. Everywhere my graph is at 0.
Did you ever have any horizontal
There's something called a midline that we'll learn tomorrow. Or yeah, tomorrow we'll learn that. But it's not an asymptote. All right, then what would I do? Like from this point, what would I do? Draw like half of a U, right? Because there's only room for half. Here I'd draw a downward U. Here I would draw the upward U. Here I would draw a downward U. And here I draw an upward U. So the blue is secant, the pink is cosine. Everybody good with that? All right, now let's go to this page. Yep. You don't have this last example?
on the right side?
You're so oh.
Is it like mixed up? Okay, so, all right, so if we look at this, this is drawing secant where it has a different amplitude and a different period, okay? When you go to do this, what you're going to do is graph what's the reciprocal of secant? What's the reciprocal of secant? Cosine. Okay, so what we're actually going to graph is this, and then from that we draw secant off of it. Okay, can you guys tell me from this what the amplitude is? 2. But actually, when you're asked for the amplitude of a secant, there's none. If it was cosine, it would be 2, okay? For the period here, we take 360 divided by, what's B? 1/2. So I'm gonna actually write this as, do you guys get it? If you take 360 divided by 1/2, that's the same as 360 what? Times 2. So shouldn't it be 720? So this means we're going to have a really wide graph, okay? And then what we have, I'm going to find, yeah, we can do this. Let's do 1/2 x equals -90, okay? And to do that, we would multiply each side by 1/2. So what this is saying is that you're going to, Owen, stop. You're going to have a vertical asymptote at -180 right here. And then you can also do 1/2 x equals +90. And when you multiply that by 2, you're going to have one at +180 over here. Okay. So when we go to do this, the big difference about this, we're doing cosine, and notice that our amplitude on this one, you have to, like, we're gonna have 4 different things that we have to change about these once we get through this chapter. But for today, you have to look at what is the amplitude, how high and how low should I go, and what is my period, okay? So we're starting at 0, and we're doing cosine. Do you guys get cosine always starts up? And because it's a 2, we start up at 2. Now, we want this entire graph to be, period, to be 720 degrees. And cosine looks like this. We only have 360 degrees to do it in, but we want this to be 720. So what point is this going to be right here? 360, right? So do you guys get at 360, my graph is going to be at a -2? You understand that? And then here is where it's 0. So your cosine is going to look like that. This is just half of this. Okay? And that's because you want your period to be 720, but we don't have 720 degrees. So we're just drawing half of that cosine function. If we had another 360, do you get that? It would end it up here at 720. So now if I go back here, here is where it would cross the 0. And then down here, I have it at 360. So my graph would look like this. Is this a whole period of that? It is, right? This is where, this is the same point as that one there, it's starting over. And isn't from -360 to 360, isn't that 720 degrees? You get that? All right, so now we have one more. So, oh, no, but I'm not done. What am I not done with?
I don't know.
You did it. You.
I didn't do the secant. Yes. Do you get that I have to, because all I drew is, yeah, I drew just the cosine. So do you get that I have to do this? Right? One more question. And then we're done. Okay? All right, so let's look this here. The amplitude would be what?
No amplitude. We ever do need an amplitude because, no, you don't.
Actually, it would be none, but the amplitude of your sine would be 3/2, right? Okay. And then here, if I go to do this, do you get that your B is 2? So B is 2. So what we would do here is we'd go 360 divided by 2, which is 180. So this, we're going to draw sine first, and the whole sine graph is only going to be 180 degrees. And then if you want to look at where would the asymptotes be for this graph, what you can do is just take 2x and set it equal to 0. So you're going to have an asymptote at x equals 0 here. And then you could set 2x equal to 180, divide by 2, and x is 90. So you're going to have an asymptote here. Okay? Now, think about sine. Sine is the reciprocal of cosecant, all right? And when you do sine, sine starts at 0, okay? But our amplitude here is 3/2, which is the same as 1.5. So I'm gonna make this 1, this 2, this 3, this 4, and -1, -2, -3, -4. So do you guys get, if I went up to 3/2, wouldn't it be like right here?
Mhm.
Yeah. And then every time you have an asymptote, that's where your graph is going to come down back and hit the x-axis. Yeah, halfway in between the two asymptotes, you're going to have your high point. And then if we finish drawing our asymptotes, it might help us. And so tomorrow, we're going to learn 2 other shifts to these graphs. So it gets to be a lot, I'm going to be honest.
Yeah,
So I don't know what we have to do with it.
When's the test on this one?
Next week,
When's the stats test one?
so it would come down to 3/2 here. It would go back to 0. Then it would go up to 1.5 or 3/2, back to 0, down to 1.5, back to 0. And so it would look like this. And then if we continued that, you'd have something like that. Are we done?
Yes.
Are you sure?
After the U's, after the U's, Bob.
Yes, I have to draw those U's.
Can I have done each line in half?
What do you mean by that?
Like, we did 1, 2, 3, 4.
Oh, yeah. So you went up to 2 and then you just went up to here, correct? Oh, no. Yeah,
Yeah, I
you
got
went up
2.
to here.
Yeah.
Yep, that would work. What you count on your axis side, you could, that would be fine. Just as long as you see both the cosecant and the sine on the graph.
You have to have them different colors.
No, but if it helps you, then yes. All right, so I do have a key for this,
Yes.
that you can look at, and I will get you the worksheet.
Get that.
You have about a half hour.
I got about 10 minutes to work and then I gotta get my,
I'm gonna make your way out.
gotta get my snow pants.
No, I got it earlier. I don't want it anymore.
You gotta get your snowshoes.
I bet Aaron. I live in snow pants over.
With the little button straps.
Are you guys thinking this is really hard?
Super hard.
I think it takes too much time.
I wish I could tell you, yes. I wish I could tell you it's gonna get easier, but it's not the next 2 days.
I really owe it.
When are we ever gonna need?
Yes, let me get all my stuff done here first, okay?
Actually,